Hello everyone, this is Professor Hitesh Matre, HOD, Computer Engineering Department of Pravin Patil College of Diploma Engineering and Technology. Today we are going to learn about the unit number 1, Program Logic Development, and the topic is Algorithm and Pseudocode. Fundamentals of Algorithm. An algorithm is a finite set of instructions that is followed and accomplishes a particular task. An algorithm is a sequence of well-defined instructions for completing a task or solving a problem. It can be described in a natural language, a pseudocode, a flowchart, or even in a programming language. It is an organized logical sequence of action or the approach towards a particular problem. A programmer implements an algorithm to solve a problem. And algorithms are expressed using a natural verbals but somewhat technical annotations. Now, algorithms criteria. In addition, all algorithms must satisfy the following criteria. So these are the conditions that is must when you are writing an algorithm. First is the input. It can be 0 or more quantities are externally supplied. Output, at least one quantity is produced, means it should give some output. Definiteness means each instruction is clear and produced, means that you are able to perform that particular step. Finiteness, if we trace out the instruction of an algorithm, then for all the cases the algorithm must terminate after the finite number of steps. Means if you check all the conditions, then after finite number of steps or after some specific number of steps, it should terminate. Effectiveness, every instruction must be very basic so that it can be carried out in principle by a person using only pencil and paper. It is not enough that each operation be definite as shown in the criteria 3. It must also be feasible. So it should be in a very simple language so that a person can understand, and it using just a paper and pencil they can be able to solve the particular problem. And it must be feasible, means the whatever the solution that is provided through the algorithm, that must be capable enough to perform in the actual or for a practically. Fundamentals of algorithms. So here you can see this is a computer system. So you have an input. So through the input, what you can do is you give an input to the computer system and it will do some processing, and then you will get an output. So how you will get an output? Because you have some problem. So when you give an input to the problem, so you design an algorithm. So using this algorithm, you try to solve this problem. So you get some input here, do the processing and give some output. So considering all the criteria, you have input here, you have output here. Then again, what you do is specific, that is finite number of steps to give you an output. So this is the fundamentals of algorithm. Notions of algorithm. An algorithm is composed of a finite set of steps, each of which may require one or more operation. The possibility of a computer carrying out these operations necessitates that a certain constraints be placed on the type of operation an algorithm can include. The fourth criterion for algorithm we assume is that they terminate after the finite number of operations. And the criteria 5 requires that each operation be effective. Each step must be such that it can at least in principle be done by a person using pencil or paper in a finite amount of time. Next is the pseudocode convention. Now pseudocode is a term which is often used in programming or an algorithm based fields. It is a methodology that allows the programmer to represent the implementation of an algorithm. Simply we can say that it is a cooked up representation of an algorithm. Often at times, algorithms are represented with the help of pseudocodes, as they can be interpreted by the programmers no matter what their programming background is or the knowledge is. Pseudocode, as the name suggests, it is a false code or a representation of a code which can be understood even by a layman with some school level programming knowledge. It is simply an implementation of an algorithm in the form of annotations and informative text written in a plain English. It has no syntax like any programming language and thus cannot be compiled or interpreted by the compiler. Every program has a name specified in its heading, and each line of algorithm is numbered to provide citation. The first part of an algorithm usually starts up with an input. Blocks within the algorithm are shown as indentations. The pseudocode conventions adopted are described as the data structures and control structures. So we will see first the data structures. Expressions are built using constants, variables, and operators as in any functional programming language, and it will yield, or that is, it will give you some definite values. The statements are composed of expressions and are the main unit of executions. All the statements are in the form of numbered lines. Declaring a variable is done as similar that is used in Pascal and C, where its type precedes its label with the possible initialization as follows, like set of integer neighbors, and it is assigned to 5. So this is what the variable is, and this is the value 5, that is the empty, that is being assigned to this particular variable. Here we declare a set of called as a neighbor of a vertex in a graph, and each element of which is the integer. Now this set is initialized to 5, that is empty value. Other commonly used variable types in the algorithms are Boolean, and for Boolean variables and message types for the possible of types of messages. For assignment, we use this arrow operator, which shows that the value on the right is assigned to the value on the left. For example, in this statement, here we can see that is A is assigned the value A plus 1, that is increments the value of integer A, and again it is assigned to the variable A. Two or more statements in a line can be separated by the semicolon, and the comments is shown by this triangular symbol at the end of the line as follows. So like this is a line number 1. So 1 is assigned to A and C is assigned a value that is A plus 2. So we are writing this in a single line, but we are separating this by a semicolon and the comment. So first we have to mention this triangle, and the comment is like C is now 3. So it is specifying that the value of C is now 3 because A is equal to 1 here. So 1 plus 2 becomes 3. Now see, these are some general algorithmic conventions. Like here you can see like this value. So value of Y is assigned to X. So this is an assignment. Then equal to for comparison of equality. Then not equal to comparison for inequality. Then true and false values, that is logical true and false. Null means it does not exist or there is a no value there. Then you have this triangular shape, so that is used to represent a comment. Then arithmetic and logical operators for negation. So for logical negation you use this symbol. For logical AND you use this symbol. For logical OR you use this symbol. XOR this. Then division, that is x divided by y, x slash y for division. For multiplication, simple x dot y or simply xy, so that indicates multiplication. Then is the set operators. So this specifies the cardinality of the set S. Phi represents empty set. This represents that U belongs to S, that is U is a member of set S. And S union R to indicate the union between the two sets. S intersection R, so this represents the intersection. For set subtraction we use here backslash. Then proper subset, that is S is a proper subset of R. Then minimum maximum value of a set, and then minimum and maximum for a collection of values of a set. So these are set operations. Then the control structures. Now first one here is an if then else structure. That is if, so here we can see in the algorithm we have given the numbers for each statement. So if condition, so that is if condition is true, then perform statement 1. Then again if condition 2, then so like this. So this is control structure. So you have conditions, and based on conditions you will be performing certain tasks. So the body of this particular if is intended. So this specifies that this particular statement number 2, 3, 4 and 5 are part of this condition. Then for else if, like here we can see So statement number 7 is a part of statement number 6, else if. So this is where you can identify the blocks here in a control structure. Next is for selection, that is case, expression, of, and then constant one and statement. These all control structures and data structures you will be studying in the upcoming topics of this particular course. For repetition, that is loops. So this is for loop, that is for I equal to 1 up to n, do certain set of statements and end the for. Similarly, while, then some expressions or condition, do particular statement and end your while. So this is the representation when you are using for loops. These are again the references that I have used to cover these topics. Set of links and set of books that are referred. Thank you.